Hey, Chem team. Just like dissolution, chemical reactions occur as a result of reactant particles colliding into each other. So we'll watch that here with these hydrogen molecules colliding into this oxygen molecule to synthesize water molecules. And we call this idea collision theory. So if the chemist wants to increase the rate of a reaction, they need to figure out ways to cause more collisions between reactant particles. So one way of doing this is just increasing the concentration of reactants. You can see a low concentration of reactants here versus a high concentration. When these reactants are more dense, more highly concentrated, they're just more likely to collide into each other and form into the products. Another way to increase the speed of reaction collisions is to crush up the reactants, because when reactants are crushed, there's more surfaces that are exposed to collisions. And so we'll look at an example of that here. We've got this whole particle that if we were to count the amount of surface areas exposed, you can see we'd have approximately 8 units of surface area exposed to collisions, where when we take these same particles and crush them up, we now have twice as much surface area exposed. Which means these reactants can react and collide a lot easier. Another way of increasing the speed of the reaction would be to increase the temperature of the reaction, because a higher temperature means the particles are moving faster. And if the particles are moving faster, they're more likely to collide with each other and form into products. And last, we can increase the speed of a reaction by adding a catalyst. Now this requires a little bit more explanation. Let's say we had 2 reactants that we're trying to get to bond together into a product. However, these particular reactants need to collide perfectly on their corners in order to bond together. That's where their bond will form. So they need to hit each other right smack dab on their corners. Now, since this is very difficult to occur naturally, what a chemist might do is add a catalyst to these reactants, which is shaped in such a way that it can actually anchor these 2 reactants into place so that they can bond together perfectly. Worth noting is the fact that after the reaction occurs, the catalyst releases the products, and the catalyst is remaining unchanged. It's just helping the reaction occur. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.